Okay, so theorem for similar triangles is our topic for today. We're going to learn two theorems about similar triangles. Before we do that, let's review. Last time, we learned a postulate for similar triangles. What was that postulate? Yes.
Angle similarity postulate.
Correct. It was the angle similarity postulate, right? Okay, Kenny, why don't you read this for us right here? So from there, we're going to actually get these theorems. Read this for us.
You can prove two triangles similar by using the definition of similar polygons or by using the AA postulate. Of course, in practice, you would always use the AA postulate instead of the definition. Why?
Why do you think we do this? We talked about this last time. Josh?
It's faster.
Yeah, because how many parts do you have to show for definition? Class? For definition of similar, yeah, 6. For definition of similar triangles, right? But for angle postulate, you just need 2 parts, right? You just need to show 2 angles are congruent to 2 angles of another triangle. Then you know that the 2 triangles are similar. Okay, now in addition to.
Oh, okay. So 2 additional methods. Oh.
In addition to the angle, Josh, we're going to learn 2 other theorems, okay? So, Josh, why don't you read this for us? 2 additional.
2 additional methods are establishing the proofs involve proportions, congruence, and similarity.
Okay, so let me give you the first one. It's called side angle side inequality theorem, okay? So, it says, did I say inequality? Similarity theorem. If 2 angles, one triangle is congruent to an angle of another triangle, and the sides including those angles are in proportion, then the triangles are similar. So what does it mean? Well, here's a picture. And it makes sense why it's called side angle side inequality theorem. Right? As you read this theorem, you need included angle to be congruent, and what about these 2 sides? That includes those congruent angles. They have to be in proportion. Okay, so write that down. And we're going to prove this. Okay. Go ahead, guys. So in this theorem, if I were you, I would actually highlight this part right here. The included angles and you have the included angle congruent, and what about the included sides? Not included sides. What about the course? Those. See, angle of one triangle is congruent to the angle of another triangle, and what? The sides, including those angles, are in proportion. So the sides, including those angles, are in proportion is important, right? Because what if they were congruent? Then you would have what? Side angle side postulate, right? Side angle side, right? The two triangles will be congruent, right? So this is different than the 2. Triangle being congruent. So how would you go about proving this? So guess what? That xy, you see that segment xy? Yeah. We're going to draw that, use that as an auxiliary line. Okay. So anyone want to guess how we're going to draw that xy? Yes. Okay, it's going to be parallel to EF, and also, are we going to draw xy anywhere on that triangle? DEF. That's parallel to EF? Or do we have to be careful in order to prove this? How is it going to be helpful? Yes?
So ABC is congruent to DX.
Oh, you want to copy that angle?
Oh, yeah.
Not quite, because we want to make sure xy is parallel to EF. What can you tell me about dx? What do you want dx to be? Equal to AB. Okay, so that's how we're going to draw this auxiliary line xy. Is that okay? Does that make sense, guys? We want to, so it says take point x so that dx is equal to AB. Can we do that using ruler postulate? Then point outside a line, there's a line that is, there's exactly one line that is parallel to that line, right? So there's that xy. So how is it going to show us that if I have angle A congruent to angle D, AB to DE is equal to AC to DF, how can we show that the two triangles are similar? Okay, before we get going, do you guys remember similarities have properties like the congruence and equality? You guys remember? Which properties did it have for congruence? Yes. Reflexive property of reflexive property. What else? Transitive property of similarity. Also, it had symmetric property of similarity. You guys remember that? That's going to be helpful for us to prove this. Who could answer what a symmetric property is? Yes. Thank you. Alright, so if A is similar to B, guess what? B is also similar to A. That's symmetric property. Alright, so knowing this, we could prove that the two triangles are similar. First, anybody have any guess to why do you think we drew XY in this way?
So there's two triangles.
Okay, so you get two triangles. What kind of triangles do you see? DXY and?
DXY and DE.
Yeah, and guess what, Jack? Those two triangles are? Similar, yes. We could easily prove that the two triangles DXY is similar to DEF. Can't you not? Who can tell me why those are similar? Brandon?
Because that
Which triangles? You're right.
the angles A and
We're not talking about those. We're talking about because we drew XY here, Brandon. Right? You see the triangle DXY and DEF? We're saying since we drew XY this way, so that DX is equal to AB and XY is parallel to EF, we could show that DXY is similar to DEF. How?
angle 1 is congruent to angle E.
Good. Angle 1 is congruent to angle E. Would you not agree, guys? Why are those two angles congruent? Kaylee? So can I just say they're corresponding angles, or if two
parallel lines cut by transversal, then corresponding angles are
good, you have to say the whole thing, right? So if two parallel lines are cut by a transversal, we know that the corresponding angles are congruent, right? So that's that. So that's good. So we could actually write that down here. So we know angle 1 is congruent to angle E. Okay, so what? Does this show us that these two triangles are similar? Why? Because what tells you that these two triangles are similar then? Michelle? Angle. But I only see one pair of angle. What's the other pair? Angle D, right? Angle D. They're both sharing that same angle. Right here. Angle D. So by angle, you know that DXY is similar to DEF. Is that okay? Okay, so what? That's what we have. And if that's true, what can you tell me about the corresponding sides of these two triangles? They're congruent. DX to DE is equal to what? DY to DF. Would you not agree? Because what? What do you know about similar triangles? Corresponding sides of similar triangles are in proportion. Okay, so that's great, but that's not what we wanted to prove, right? What do we want to prove? If angle A and angle D are congruent, and if AB is over DE is equal to AC over DF, the two triangles are similar. That's what we want to show. So what should we do next? Jack? One person sees it? Oh. Okay. So what?
You could somehow say AC, some side is in proportion from one triangle.
Yes. So, what do we know about dx? Look what we had here. What's dx equal to, guys? So if dx is equal to AB, and isn't this given?
Yes.
So if dx is equal to AB, can I replace AB with dx?
Yeah.
By substitution, right? So let me write dx over here. So if dx over d is equal to AC over df, and we know that dx over d is equal to dy over df, what can you tell me about AC and dy? They are equal to each other, aren't they?
Yeah.
Would you agree?
Yeah.
Yes? Okay, so we just said that AB is congruent to dx. What do you mean about AC now? AC is equal to dy. So what? What do we have in terms of triangle ABC and dxy? Two triangles are congruent by side angle side. Would you not agree?
Side angle side.
No, side angle side, right? The two triangles are congruent, right? By side angle side.
Yeah.
If two triangles are congruent, are they also similar?
Yeah.
Yeah. What's their scale factor? Yeah, and you could also use angle-angle similarity theorem on that, right? If two triangles are congruent, right, you could use angle-angle similarity. So what? How does that help us to show that ABC is similar to DEF? One person see everybody go ahead and think about this. I'll give you time. What do you think? What do we do next? Let everybody think about it. So do we all agree that if triangle ABC is similar to, congruent to triangle DXY, as it says here, do you agree that I could say this? ABC is similar to DXY, the two triangles? Yeah?
Because it's something.
Yeah, we just said that. Now, how does then this help us to show, because I'm claiming to you that we're almost done.
Oh, that means.
Anybody see why we're done here? Jocelyn?
You use the transitive property of similarity.
Now we use the transitive property of similarity. How so? You're right. Somebody I haven't picked today. Anybody else see it? Go ahead, everybody talk to your group. Come on, you should all be able to see this. How is that we're using? How can we use this to prove? Okay, so as we said, we could use, guys, it says by transitive property of similarity, we could say this, right? ABC is similar to DFE. Who sees that? How is it that we're using transitive property of similarity? How about, that's it, same people that we had before? Oh, okay. Maddie, what do you think?
You'd have to say after you said triangle ABC is similar to triangle DXY, that it's similar to triangle DXY is similar to triangle DE.
Exactly. Look, didn't we say this here? Triangle DXY is similar to triangle DEF? Oops, sorry. Here, can you see that better? Right? And what else? What do we know about triangle ABC and DXY? Because they're congruent, aren't they also similar? And do you see how this is similar to DXY? DFE is similar to, so by transitive, guess what? If A is similar to B and B is similar to C, what do you know? A is similar to C. Do you see how that works out? That's why we get this. Okay, from these two. Okay? I'm sorry? We did? How so, Brandon? Yeah, we didn't have this yet, right? We had separate triangles that are similar. We said that, right? Triangle DXY is similar to DEF, and we just showed that ABC is similar to DXY. Correct? So since DFE, yeah, so thereby transitive, you see that. Okay, we haven't said that one yet. Does that make sense?
Yeah.
Okay, so this, what is this called? It's called side angle side similarity theorem. And do you see why this is true?
Yes.
Okay. All right, may I go to the next theorem? Since we have side angle side similarity theorem, anyone who guess what the next one is? Yes, sir. Well, angle side angle, that's kind of like AA, similarity postulate. So side 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 similarity theorem. So let me move that up for you. There you are. Side 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 similarity theorem. Go ahead and write this down. If two sides of two triangles are I'm sorry, not two sides. I keep saying two. If the sides, we need all sides. If the sides of two triangles are in proportion, then triangles are similar. Here is the picture. And of course, we're going to see how we're going to prove this, okay? So if two sides of if the sides, okay, all sides, okay? Just having two doesn't help. If the sides of two triangles are in proportion, then the triangles are similar. Go ahead, write this down. And think about how you go about proving this. It's very similar to the one we just did, okay? So, Any guess as to how we're going to prove this? First of all, any guess as to how we're going to draw xy here?
Equal to AC.
Same way as before. How are we going to draw dx? Anyone? Yes.
So that's congruent to AB.
Yeah, so that it's congruent to AB. And guess what? Through x, we're going to draw a parallel line to EF. Right? And there's exactly one line that's like that. Right? Question?
If you're writing a proof, would you have to say, the singular function?
For x, there's, right, 1 point. Okay, so then, after you have this, just like before, by angle, do we not have the two triangles similar? dxy similar to def? Right, guys? So it's going to be very similar. If I have that now, and of course, dx and dx to de is equal to xy to ef, and dy to df. Because of what? What do we know about corresponding sides of similar triangles? They are in proportion. Okay, so all we have to say is, similar to last time, if I could show that triangle ABC is congruent to triangle dxy, I'll be done. Is there a way to do that, knowing this? Right, it's very similar, but this time what's given to you is a little bit different, isn't that right? So you're given that all three sides are in proportion, and you have this now, since we show that triangle dxy is similar to def. Is there a way to show that triangle ABC is congruent to triangle dxy? Because if I could do that, then I'll be done, just like before, right? I could use the transitive property of similarity to show that the triangle ABC is similar to the triangle def, right? So the key is, how do I show triangle ABC is congruent to triangle dxy?
We know angle D.
Right, we don't have angle A congruent to angle D anymore, do we? Because that's not given to us anymore. Because it's side, similarity theorem. We just know that the three sides, right, of these triangles are in proportion. Go ahead, everybody think about this. I'll wave. Think about it as a proof. Think about this. So if we can show that triangle ABC is congruent to triangle dxy, right? Then we know these two triangles will be similar, right? Because if they're congruent, they're also similar. And by using transitive property of similar triangles, by using transitive property of similarity, we could say triangle ABC is similar to DEF. But then the problem is, how are we going to show that triangle ABC is congruent to triangle DXY? Some of you said, wait a minute, just by knowing this, that all sides are in proportion, doesn't that make these two triangles similar?
Yeah.
Well, that's what this theorem is trying to say. We don't know that yet. Do we? Because can we use the definition? Not quite, because definition shows, yes, this part is the second part. But what about corresponding angles being congruent? This doesn't say anything about corresponding angles being congruent. Do you understand? Do you see where Do you see where we're going with this? Yes.
I think, isn't DE in proportion to AB? So, and no, you also know DEF is.
Yeah, that's what it says. Yeah, AB over DE is the same as BX, BC over EF,
So
and AC over.
DEF is similar to DXY, right? Because.
Yeah, we said that. DEF, the one, DEF, the big triangle, is similar to DXY, yes? That's why we got this. That's how I got this, right?
Can we use transitive somehow to say ABC is?
Okay, kind of. So it turns out it's not so bad. Look, what do we say about DX and AB? Just like before, we know that AB is what? Equal to DX. Would you not agree? So look at this and look at this here. What can we replace DX with? As soon as I do this, I get AB over DE. AB over DE equals to here. It says BC over EF. It says XY over EF. Guess what? Multiply both sides by. What can you tell me about XY and BC then? They are equal, aren't they? Right? By transitive or substitution. You know that AB over DE is equal to BC over EF, right? And we know here we could replace DX with AB. So let me write this down. Then BC over EF is equal to what? since these are both AB over DE, by transitive, what do you know? BC over EF is equal to XY over EF. Multiply both sides by EF, what do you get? BC is equal to XY. Right? Isn't that nice? What else could we do? Could we now use, let me do this with blue. Can I use this one equal to this? And this equal to this now? So now AB over DE, right? Is equal to AC over DF, DY over DF. So AC over DF is equal to what? Whoops, DF. Is equal to what? DY over DF. Right? Because we replaced DX with AB, remember? Right? Because that's how we drew this. So that's what? Multiply both sides by DF, what do you get? AC is equal to DY. Guess what? These two triangles are congruent by side. If two triangles are congruent, guess what? They're also similar. And there's ABC similar to DXY. And what else do we know? DFY is similar to DXY. So guess what? ABC by transitive property of congruence. Transitive property of similarity. What do you know about ABC? So let's write this down. We got a triangle ABC similar. Triangle ABC similar to triangle DXY. Also, what do we have? Let me write this using. Can I write DXY first? Triangle DXY is what? Similar to DEF. Correct? So by transitive, what do you have? Triangle ABC is similar to triangle DEF. And isn't that what we wanted to show? And there it is. Right? Does that make sense? Hello? Yes? Do you see how it's very similar? And do you see how to show that the two triangles are congruent? ABC and DXY. Does that make sense?
Yeah.
Hello? Yes? Okay. Then let's move on to some examples. Okay? Somebody read this for us. It says, to prove two polygons similar. Go ahead, Michelle.
To prove two polygons similar, you might need to compare the corresponding sides. As shown in the example below, a useful technique is to compare the longer sides, the shorter sides, and so on.
Yes, and it's because, take a look at this example right now. Let's look at A. When you have similar triangles, it is important, it says useful technique is to compare the longer side with the shorter side and so on. Because if you don't do this correctly, guess what? Will the corresponding sides be in proportion? No. Does that make sense? So take a look at this example 1. Okay. If I have this triangle on the right side, they tell us that RS is 18, ST is 15, RT is 10. And then the one on the right, WT is 6, ZT is 9, and WZ is 10.8. Could we show that these two triangles are similar, just having this information? What do you need to show if they are similar? Using which property that we just learned? Or theorem we just learned? Josh? Side, what? Similarity theorem, right? Does it work? Well, we have to verify. So look at RS. Which one are you going to compare RS with? Is it WT? No, you have to compare with WZ. Krista, why WZ?
Because they're corresponding sides.
Yeah, and how do you know that? Why not ZT or WT? Why does RS go with WZ? Because that's the longest side of these two triangles, isn't that right? Right? You see what I'm saying here?
Yeah.
No, Jason? Oh. Did you not understand? Oh, okay. Because you were shaking your head. Oh. Okay, then what about then RT, Jason? What are you going to compare that with? RT and? WT? That's correct, because RT is the shorter side of that triangle and WT is the shorter side of the other triangle, right? If these two triangles are similar, right, the longer side would have to match with the longer side and the shorter side has to match with. And of course, you only have ST left. ST with what, class?
ZT
ZT, and do they all become, will the proportion all be same? Will the ratio all be same? That's what you're verifying, right? Go ahead, everybody try. See if you get the right answer. Take a look at it. So RS to WZ, as we said, these are the longest sides of these two triangles, isn't that right? So what do we get? RS to over WZ is 18 over 10.8, which is what? What is it? 5/3, right? 5/3, isn't it? Correct? Isn't it 5/3? Okay, let's compare then the shorter size, which is RT over what again? RT over WT, which is what? 10 over 6, which is again? Okay, we're done. Then we could say these two triangles are similar, correct? No. We only compare two pairs. You have to have all of the three sides. Okay, so then we're gonna compare the remaining side, which is ST to ZT, which is 15 over, which is now are we ready to say? And what is the reason that these two triangles are similar? Because of side. Similarity theorem, correct? Try B now. What if I told you angle 1 is congruent to angle 2, and WZ over RS equals to TZ over TS? Go ahead, everybody think about this. Can we say for sure that these two triangles are similar? Go ahead, everybody think about it. How many people think that, yes, these two triangles are similar with given information with B only? Okay, that's not all of you? What about who say, no, they're not similar? Wait, aren't these, isn't B similar because of side angle side inequality, side angle side similarity theorem? No, it's not. They're not similar. Why not? Who can tell us? Who sees it? It's sort of tricky because look, it looks like they gave you the angle and then they gave you the right size, right? They're in proportion. Yes. Exactly. In other words, look at these two sides. WZ, where's WZ? WZ and TZ. They need, do we need angle 1, 2 or the ones on top? We need the what? Ones on top. Is angle 1 and 2, are those the course included angle? No, so guess what? B is, they're not similar. Does that make sense? You cannot say for sure. Any question?